Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 6.1.2. We're going to start with a couple of expression comparison maths. And I would like to first say that one of the things that I'm not crazy about with these maths is when you go through the trouble of creating one or drawing all these x's and negative x's, ones and negative ones, and then you start marking things out, it really becomes a mess very quickly. And so it's part of the reason why I've left it as a mess right here, just so you can see that it gets a little bit crazy sometimes. So you really want to be careful and do it slowly and make sure you're doing it right the first time that you do it. Because when you go back and look over it multiple times, it may not look right. I mean, it may just look like a complete mess, and it's hard to draw any conclusions from it. So if we just make sure we're very careful at the beginning, this should go well. Okay, so our task here is to determine which mat has the greater value. And I think everyone can agree when you first look at this conglomeration of x's and ones and negative ones, it's really hard to tell. So the first thing you should do is for each mat, copy down the expression. So for mat A, I've got 1, 2, 3, 4 x's, 2 negative x's, 2 ones, and 1 negative one. And for mat B, I've got 1, 2, 3, 4 x's, 2 negative x's, 1, 2, 3, 4, 5, 6 ones, and 1, 2, 3, 4 negative ones. All right. So if you know how to combine like terms by just focusing on the number parts, 4x's plus negative 2x's, you just take 4 plus negative 2, and you get 2 for an answer, right? So it would be 2x's. And then you've got the integers where 2 plus negative 1 is positive 1. So you can simplify this algebraically, and that is absolutely the direction we want to go in. But until we become experts at this, the maths are helpful. They are useful for giving you that visual representation of why we're removing different parts here after they've completely canceled out using our basically integer rules of how to add positive and negative numbers together. So there is a reason why we do this. So let's just go through the process. Now, what we're supposed to do here is we're supposed to start by removing 0 pairs. So I'm going to do that, but I'm going to do it, I'm going to color coordinate it like I've done it here. Every place where there's a 0 pair, I've made a red mark. And any place where there's a blue mark, that's where I remove balanced sets. That is, I took the same amount from mat A as I took away from mat B. So it's kind of like that balance thing where if you take away the same amount from each side of a balance, it stays balanced. If you add the same amount to each side of a scale or a balance, it stays balanced, right? So property of equality there. So we start off with these two guys where you got 2 x's and 2 negative x's would cancel each other out. You've got a positive 1 and a negative 1 that cancels everything out. So on the mat, on the left, mat A, we've got, these are the 0 pairs that have been removed, but you could still have 2 x's and a 1, right? So that's what happens here. You'd still have the 2 x's there, and you'd still have the 1 there. On mat B, you'd have, here's a 0 pair, 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 and here is a 0 pair. When all is said and done, we still have 1, 2 x's and 1, 2 ones. So 4 x's minus 2 x's is 2 x's, and 6 minus 4 is 2. All right, now let's remove balanced sets. If I take away these 2 x's from the left, I have to take away those 2 x's from the right in order to keep everything balanced. And then when I take away a 1 from the left, I take away a 1 from the right. And what do we have left over? This is the only thing that hasn't been taken out. It's the positive 1 that's on mat B. Everything has been canceled out here, so you got nothing there. So you got the 1 on the right and nothing on the left, which makes B the greater because 0 is less than 1, which makes 1 greater than 0, and mat B would be the winner here. That would be the greater. Looking over here, let's do the exact same thing. Let's take all the 0 pairs, positive x and a negative x. A positive x and a negative x cancel out those zeros, and then a positive 1 and a negative 1 make a 0 pair, leaving you with 3 x's and 2 1's, right? 5x minus 2x is 3 x's, and 2 minus 1 is 2. So 3 x's plus 2, 3 x's and 2. On the right side, you got a 0 pair here, you got a 0 pair here, 0 pair there, 0 pair there, a 0 pair here, and a 0 pair there. All of those zeros, and what we have left are 2 x's and 2 1's. So 5x minus 2 x's. Wait, how many x's do I have there? Oh, I've got 3 x's. 1, 2, 3 x's plus 2, and 1, 2, 3 x's plus 2. Ah, look at there. Turns out now when we remove 0 pairs, you take away 3 x's from the left, 3 x's from the right, 2 from the left, 2 1's from the right. There's nothing left. Everything either got zeroed out or removed as balanced sets on both the A map and the B map, which means there's nothing. They're both equal, same amount. So when you remove everything from both sides, where 0 is equal to 0, then that means that both sides had to have been equal in order for that to happen. All right, when solving a problem about the perimeter of a rectangle, using the 5D process, Herman built the expression below. X plus 4x plus 4x feet. A rectangle that would match this expression. So there's your rectangle where the 2 sides are x's and 2 sides are 4x's. What is the relationship between the base and the height of this rectangle? Well, the base is 4 times the height, right? And then if the perimeter is 60 feet, work through the 5D process to solve the problem. So you can do it 2 ways. You can either set up side 1, side 2, side 3, and side 4. You know that sides 2 and 4 are 4 times side 1 and 4 times side 3. So if this is 5, this would be 20, this would be 5, this would be 20. You add all those together and you get 50, and that's too big. If this is 8, then this would be 32, this would be 8, that would be 32, but then you add those together. Wait, did I say 50 was too big? It's too small, it's too low. 80 is too big. 80 is way more. And since 50 is closer to 60 than 80 is, then my next guess, I'm going to get closer to 5. So I'm going to go back to the 6. 6 and 24, 6 and 24 adds up to 60, so that is the correct answer. Now, let me solve this algebraically. The formula is going to be, where are you? 1, 2, this is going to be 8, 9, 10 x's, right? 10 total x's is equal to 60. I'll solve it right here. If 10 x's is equal to 60, then when you divide that by 10, 60 divided by 10 will tell you what x is. X has to be 6. So that means, let me go ahead and do this in this right there. So if this is 6 right here, then this has to be 24, then this would be 6, and this would be 24. And lo and behold, 30 and 30 gives you the 60 that we needed. There it is. Your magic trial number is 6, and you're ready to go and declare your answer. So the width is 6 feet, and the length is 24. All right, order of operations. Not going to work through any of these unless someone asks me to do it. You know, PEMDAS, we've been practicing this a lot. You should be experts at this now, being able to take any numerical expression and know to do the parentheses first, then do exponents if they exist, then do multiplication and division, and the last priority is adding and subtracting from left to right. All right, write each of the following expressions in 2 ways. One with parentheses and one without. So the one with parentheses is always going to involve distributive property, right? So it says a number reduced by 8 and then multiplied by 2. So I want you to pay attention to this. If a number is if a number is reduced by 3, that means that was a subtraction problem. But look at this word right there. That is an ordinal kind of a direction. It tells you the order that this has to happen. It says do the subtraction, then multiply by 2. If you're going to do the subtraction before multiplication, you've got to incorporate parentheses into your problem, which would tell the person doing the math that they have to give the subtraction priority over the multiplication. Okay, so that's what all of these problems are doing, is they're giving you a direction to either add or subtract first before multiplying. And the only way you can do that is if you include parentheses around the addition or subtraction problem. So a number reduced by 3, then doubled. Once you've got that written as an expression with parentheses, then you can rewrite it a second time using distributive property 2x minus 6. Here it says a number increased by 7. So you have to do that first, put that in parentheses, then multiply times 5. So here's the first expression, there's the second expression after using distributive property. Then the last one says 10 times a number and then add 20. Well, okay, well that is actually the right order, right? You're supposed to multiply first and add at the end. So how do you write this as parentheses? Well, this is where we do the factoring. If you recall a lesson that we learned a couple chapters ago, you can take this expression and do the reverse order of distributive property, and we call that factoring. So what do these two numbers have in common? They have the number 10 in common, right? What would you multiply times 10 to give you the 10x? Well, that would be the x, right? And what would you multiply times 10 to give you 20? That would be the 2. So inside the parentheses, you're going to put the x plus 2 so that when you send in the dive bombers, it becomes that expression. Is this the last problem? I think it might be. No, we got one more after this. All right, graph these points on a coordinate grid and connect the points in order. And what shape have you created? Well, it looks like these sides are parallel to each other, and these sides appear to be parallel to each other as well. When we get into 8th grade algebra and we are working on slopes of lines, we will be able to prove that slope ratios of this segment and this segment are exactly the same, and the slope ratios of this segment and this segment are exactly the same, which proves that they are parallel to each other. So when you've got a four-sided figure where the opposite sides are parallel to each other, that is referred to as a parallelogram. We have enough information to determine whether or not these are all the same length. That would make it a rhombus. I don't think we know for sure right now. We could find out, but I would have to teach you an advanced formula called Pythagorean theorem, and we're not going to go there right now. So let's just say it's a parallelogram. We'll be good with it. And now for the last problem. Alan was paying a dinner check but was not sure how much he should tip for his bill of $27.38. If a 15% tip is standard, how much should Alan leave for his server? Okay, so we want to find 15% of $27.38. So if we say, what is 15% of $27.38, many of you have learned that whenever you're solving a problem like this, you can change the percent to its decimal form, and the word of means to multiply. And so if you take your calculator and multiply 1/1500 times $27.38, that will give us our answer. Okay, I'm going to leave that here for now. I'm going to prove it that we're going to get the same answer doing it that way. The reason why this way is sort of challenging, though, is because sometimes they tell you the part and not the total, in which case you would not want to multiply these two numbers together if this was the part. So this is where I think it's a really good idea to remember our percent proportion that we learned in chapter 4, I believe, where part over total is equal to, or maybe that might have been the beginning of chapter 5, is equal to percent out of 100. So that's the total bill, right? And we want to find 15% of that, which would represent a part of the total bill. So this is going to be our total, $27.38. We just don't know what part of that will represent the tip, which is 15%. Okay, this isn't actually a great example of a part total relationship. This is sort of different, but just understand that you want these, this can't go in the numerator because that would correspond to the 15%, and that would make the total be something like, what do you multiply times 15? Almost 6, like 6.2 or 6.3. So we're not going to have a tip that's going to be like 150 or $160, right? That doesn't make any sense. So in this particular situation, the tip is going to be less than the total, so the lesser part goes on the top and the bigger part goes on the bottom for the total. Work with me there. That is how this would work. So can we find a giant 1 here? I'd rather not. Let's go ahead and cross multiply. So you get 100 times x is equal to 15 times 27.38. So let's take that. 27.38 times 15 is 410.7. And now we need to solve for x, so we're going to divide that by 100. And when you take 410.7 divided by 100, you technically get 4107. You would get this. But we need to round that to the nearest penny, so this would round up to $4.11. All right, let's see what we get here when we multiply 1500 times that same number. 0.15 times $27.38 is 4.107. Same exact answer, right? So what is going on here? When we solved it this way, or when I solve it this way, I am dividing 15 by 100 at the beginning of the process and then multiplying that number times $27.38. When we did it this way, we started by multiplying 27.38 times 15 first, then we divided by 100 at the end. So since multiplication and division are like partners of each other, it really didn't matter which one we did first. Either way, you're going to multiply and then you're going to divide by 100. It just, when you choose to do it, doesn't really make any difference. So if you think this is a quicker way to get to your answer and it totally makes sense, go ahead and do it that way. My preference would be to have students use this because if you just think through the problem to identify, is that the part of the total, that's the percent, put it in the appropriate place. If indeed this was a problem where they said the tip was $4.11, which was 15% of the total, how much was the total bill? Then you would put the tip on the top and you'd have to solve for that, and you would get that as your answer by working through this process. So I'm a big fan of this process. I encourage you to practice it. All right, I think that ends our lesson or our homework. Let's move on to our next activity, which I believe is a lesson. Take care. Hey, stop it.
Hey, feeling